Welcome to this explainer. We're going to strip down the invisible machinery of reading and figure out exactly where artificial intelligence fits into the whole process. We're living in a world completely overflowing with text, screens, and instantly generated language everywhere you look. So just asking, can someone read? Well, it's just not enough anymore. The real question is, can they understand, judge, and actually use what they're reading? So settle in, because we're going to look right under the hood of human literacy. Okay, let's dive right in with a pretty fundamental question, one that kind of shatters a common illusion. Do we think of reading as just this innate gift? For the longest time, society has treated reading like a natural talent, right? Like you either just naturally get it or you don't. But honestly, when we look at the actual science of reading, we realize that assumption completely misses how our brains actually operate. The foundational truth here is that reading is actually a complex, highly coordinated, completely invisible system. It's definitely not just one isolated skill, and grasping this distinction is absolutely crucial right now in our digital age. When the system is firing on all cylinders, it feels totally simple and effortless. But the second any single part of that system slows down, you suddenly realize just how much heavy cognitive lifting is happening all at once. Section 1. The invisible reading system under the hood. First up, we've got an irreducible truth. Written words are not naturally meaningful. Think about it. Letters are literally just arbitrary shapes, squiggles on a page. Your brain has to actively convert those marks into a language it already knows. It's kind of like a locked gate. The symbols you're looking at, that's the gate itself. The sound and the meaning are what's locked behind it, and your brain has to literally forge the key to unlock it, and do it really quickly. And this brilliantly illustrates that reading is fundamentally a relay race, not a solo sprint. First, a reader has to notice the letters, then connect them to sounds, recognize familiar patterns, pull up the meanings, and then, here's the kicker, hold all those words in memory long enough to actually build a cohesive sentence. Each part is basically passing the baton to the next. If just one system drops the baton, if even one runner stumbles, the whole process drags, and that deeper meaning just fails to fully assemble. Section 2. Decoding versus comprehension, understanding the text. Now, let's contrast decoding with comprehension. Decoding is really just figuring out what the printed word says, getting a clear signal. Comprehension, on the other hand, is figuring out what the language actually means. Think of it like tuning an old school radio. Decoding is just twisting the dial to the right station to clear away the static. Comprehension is actually understanding the lyrics to the song once it's playing. Someone might read super fluently on the surface, but that can sometimes hide a really weak understanding underneath if they aren't actually grasping the meaning of the song. So to really understand why that reading fluency matters so much, we first need to talk about working memory. Working memory is essentially the brain's short-term workspace. It temporarily holds pieces of information active while you're trying to connect them all together. But, and this is a big but, it is highly, highly limited. Imagine working memory like a really small, crowded kitchen counter. If you're using up literally all of your counter space just trying to chop the vegetables, or in reading terms, putting all your mental effort into just identifying individual words, that counter gets completely overloaded. There's zero space left to actually assemble the meal. That meal is the meaning of the sentence. Fluent decoding is an absolute game changer because it frees up space on your mental kitchen counter. And it goes beyond that. Prior knowledge isn't just some nice-to-have bonus. It acts as the essential scaffolding required to actually build meaning from a text. Reading doesn't happen in a vacuum. Your brain relies on what you already know to fill in the blanks and make sense of implied ideas. Two people can read the exact same paragraph and walk away with totally different takeaways, all depending on the mental scaffolding they brought to the table. Section 3. AI, patterns versus meaning, where AI fits in. We really have to face a hard truth here. While AI can generate language that perfectly mimics human understanding, it operates purely on statistical patterns. It's basically predicting which words relate to other words based on massive data sets. It is not true human meaning. A lot of people see AIs spit out this incredibly fluent text and just assume, wow, it understood that. But remember our rule from earlier? Fluency is not the same as comprehension. AI is a tool to support the chain, for sure, but it is definitely not a human reader. So the absolutely crucial point here is embracing what we call productive friction. AI is so incredibly tempting because it completely removes friction, right? It instantly explains, rewrites, and hands you the answers. But when it comes to literacy learning, a certain amount of friction is exactly where the learning happens. When someone has to slow down, notice a weird word, and test out a meaning, their brain is doing vital construction work. If AI just jumps in too early and makes everything perfectly smooth, it can literally short-circuit the learning process and stop that internal mental model from ever being built. Section 4. AI as a thinking partner, not an answer machine. Now, AI is incredibly powerful if we use it as temporary scaffolding. A really good literacy tool helps the learner notice, compare, and test out ideas. For example, AI can be great at exposing the hidden structure of a text, like outlining the main claims and evidence. It can give you controlled repetition by rephrasing a tough concept in a few different ways to help build familiarity, and it can even generate feedback loops, pointing out where your reasoning might be a bit fuzzy. But, and this is key, this only works if the human learner is still doing the cognitive heavy lifting. Picture a universal classroom scenario where students are tackling a really dense science chapter on ecosystems. The vocabulary is brutal, the concepts are super abstract. A teacher might use AI to rewrite a tricky paragraph into simpler language just to get the kids engaged. But the real aha teaching moment doesn't happen by just reading that simplified AI version. It happens when they compare the AI summary back to the original text. They start asking, okay, what did the AI simplify? What did it leave out completely? Does the core meaning actually still hold up? That back and forth comparison forces them to actively practice reading judgment. When we break down the exact boundaries between human and machine, it's fascinating. AI is fantastic at access and support, things like reading aloud, simplifying, summarizing, and organizing. But the human, we have to handle meaning, practice, and judgment. The human has to decide what matters, compare interpretations against the original, try to answer the questions, and evaluate if it's actually accurate. That boundary isn't some flaw or weakness in the AI. Honestly, it's the entire point. Section 5. The Human Literacy Boundary Beyond Generated Text. We have got to shift our mindset away from this totally obsolete question, how do we make reading easier with AI? If we just make it easier, we strip away all that productive friction we just talked about. Instead, we need to be asking a much better question. How do we strengthen the reader without replacing the reader? Making that shift forces us to actually value decoding practice, deep comprehension work, human reflection, and critical judgment instead of just marveling at the speed of generated text. Ultimately, artificial intelligence is an incredibly powerful assistant. It can reduce your cognitive load, model how text is structured, and drastically open up access for so many learners. But AI cannot replace the internal, invisible work of making meaning out of symbols. At the end of the day, the ultimate meaning-making engine is always going to be you. Literacy lives firmly and exclusively in the human mind. So as you're out there evaluating all these shiny new reading technologies, don't let yourself be fooled by a dashboard spitting out fluent-looking text. Always, always look at the machinery running underneath. Leave yourself with this final, absolutely vital question. Does the AI tool you're using actively build human understanding, or does it bypass it entirely? The entire future of literacy depends on your answer.